morning. Today we're going to talk about Module 3, Lesson 5, What's Up with Eclipses. And in this lesson we're going to look at solar eclipses and we're going to look at lunar eclipses. They have two videos that are embedded into the lesson. You want to make sure you take a look at those. The first one is a solar eclipse, and it's some 2017 solar eclipse. And they have a video of what a lunar eclipse looks like. You want to make sure that you can tell the difference between the two because they're in some of the assignments. So this is the lunar solar eclipse from August 21st, 2017. You might have had a chance to look at it. If you're at KO, we went out and looked at it. And then the lunar eclipse was January 31st, 2018. It was kind of special because it was a blood moon, and it was a blue moon, and it was a super moon all at the same time. The blood moons is when there's a total solar eclipse and the moon appears to be this reddish color. Blue moon means that there is a second full moon of the month. In Halloween this year, we're going to have a blue moon. So the first one's going to be October 1st, and that's going to be a harvest moon. And then on the 31st, we're going to have a second full moon, so that makes that a blue moon. And then the third thing it was a super moon. And a super moon is when the moon is closer in orbit than any other time, so it appears to be larger. So that was a super blue blood moon. So what they want you to do next is your assignment for this lesson is you're going to post on the discussion board. You're going to use your prior knowledge of the Earth, Moon, and Sun system to create a model to explain the differences that you saw in the video. You're going to draw an eclipse and tell me why a lunar eclipse is different from a solar eclipse. So a solar eclipse are more common than a lunar eclipse. The solar eclipse can happen between 2 and 4 times a year, but a lunar eclipse, the maximum is 3 times a year. So what they have you doing first is they're going to have you find a small round object. They describe it as a candy in the lesson, and you are going to put it in front of your face and point it at something across the room. They describe a neon light. But you don't have to use a neon light. Sitting here at my computer, I used a Gatorade cap, and I moved the Gatorade cap in front of my face, and I moved it out. I was looking at a picture across the room, and I'm going to move it across the room until it completely blocks out the picture. And I'm going to move it closer and watch what happens as I move it closer and farther away. I found that if I closed one eye and did it, it seemed to work a little bit better than if I try to use both eyes. There is an investigation that you're going to answer in your notebook, and it's going to ask about patterns that you saw. So as you do that, I just sat in my chair and did it, but you want to move around the room. You want to get a little bit closer to the picture across the room. You want to get a little bit further away, and then you want to move the cap in and out. And then they're going to ask you what each thing represents. What is the neon light? What is the candy? And what do you represent? And you need to remember that those are the parts of an eclipse. There's going to be the sun, there's going to be the moon, and there's going to be the earth. So you have to figure out which one represents which in a solar eclipse. In a solar eclipse, you can have different kinds. You can have a partial solar eclipse, and I have a picture over here. A partial solar eclipse is when only part of the sun is blocked out. The moon does block some of the sunlight, but it only marks part of it. The moon must be a new moon for a solar eclipse and a full moon for a lunar eclipse. The new moon is between the sun and the earth, which would make it a solar eclipse, and a full moon is on the opposite side of the earth, which means the earth would block out the light to the moon. There's 2 nodes, and if you look at the diagram on the right, you can see that the moon doesn't actually go in a flat plane with the earth. It's on about a 5-degree tilt. So as the moon orbits the earth, there's only 2 times, or nodes they call them, when the moon is directly between the earth and the sun. And that's when you can have your total eclipse. So that would be similar to you holding up, in my case, the Gatorade cap of the picture. If I held it too high, I would not block out the picture at all. If I held it too low, I had to hold it at the right angle to make sure that it was between my eye and the picture to block it out. If the moon is too far away, if you moved the Gatorade cap too far away from your eye, you couldn't block out the whole picture. And that's similar to an annual eclipse. And that means that the moon is too far away and it blocks out some of the sunlight, but it doesn't block out all the sunlight. The other thing that they talk about with a solar eclipse is they talk about the path of totality. And when you look at this, this is a path that the shadow is going to follow across the Earth. When you have a solar eclipse, the shadow only blocks out certain areas of the Earth. You can have a total eclipse for some parts of the Earth and only have a partial eclipse for other parts of the Earth. And that's because of the perspective and where the shadow falls on the Earth. As you're watching a solar eclipse, there's some different things, and you watch this in the video. One of the kids yelled out, "They're the beads." And these are called Baily's beads. And what these are is this part of the light was not blocked out because of the craters on the moon. So the craters will block some of it, and some will come through, and it makes it look like a string of beads, and they're called Baily's beads. And the very last part of light, right before you have the sun completely blocked out, is this part, and it's called a diamond ring. And once the moon is directly in front of the sun, you have a halo, and that's formed because of the corona of the sun. This is a diagram of a solar eclipse, and you can see that the moon is between the Earth and the sun, and the moon is blocking out the sunlight. So you have a shadow. The whole Earth is not in a shadow. The path of totality would be where this is hitting the Earth. And as it rotates and it moves, the path of totality will move across the globe. And then this is a lunar eclipse. And a lunar eclipse, the Earth and the moon are in opposite places. In this case, the sun is here and the Earth blocks out the light to the moon. And this is where you get that red color, because you have two different parts. You have an umbra and a penumbra that are shadows that are blocked.